So now we'll find exact values of all of these inverse trig expressions. And you notice that we have one of each here, all 6 of the trig functions, but we didn't talk about 3 of them, but that's okay. We don't need to because of things we know from the past. So all of these have exact values. Like I said, they're all special ratios, so we just have to kind of reason out where they belong. So first one, inverse sine of root 2 over 2. Remember what I'm finding the angle theta, so that sine of theta is root 2 over 2. And that you might remember as 45 degrees, which I can write it that way in degrees, or I can write it this way in radians. And that's usually the preferred answer is the radians. So if you have to use degrees to get to the radians, I'm not going to judge. You do you. That's going to work out just fine. Cosine inverse of negative a half. Well, remember that cosine inverse is only going to return an angle in quadrant 1 or quadrant 2. Since cosine is negative, I'm looking for theta, so that cosine of theta is negative a half. So I know that my triangle is in the second quadrant, and I know that my cosine is negative 1/2, which means this is root 3. So that means, let's see, what does that angle have to be? Well, what angle is opposite the root 3? That's the 60. So that means that this is 120. So that means that theta is equal to 120 degrees. Or if you're converting to radians, 2 pi over 3. Okay, so there's the inverse sine and the inverse cosine. Let's look at an inverse tangent. So here again, we have a negative ratio. Inverse tangent kicks back an angle in either quadrant 1 or 4. This must be 4 because of the negative ratio. And just to remind you that this is the rationalized form of negative 1 over root 3. So if this is my angle that I'm going to call theta, opposite is negative 1, adjacent is root 3. And notice that those signs match up because negative 1 goes down and root 3 goes to the right. Gee, I wonder what angle that is. That looks like a 30-degree angle. So that means our final answer is negative 30 degrees since we're fourth quadrant, which is negative pi over 6. So there's our inverse tangent. Now, inverse cotangent of 0. We did not talk about an inverse cotangent function, but we don't have to. Because remember, what does this mean? This means cotangent of some unknown angle gives me 0. Gee, that might be tougher, but if you go back to your unit circle, you would see that theta is 90 degrees, okay, which is also pi over 2. Now, how do we know to do that? Well, cotangent, remember tangent was y over x, so cotangent is x over y. So if you think of your unit circle, where is the x coordinate 0? Right there, okay? So there we have that. Secant inverse of negative root 2, well, let's just follow on the line here. So we have secant of theta is negative root 2, which means I'm going to write it in terms of its reciprocal function, which is cosine. I know that means cosine is the reciprocal of that, which is negative 1 over root 2. And now, keeping in mind the quadrants, so that has to be either quadrant 1 or 2. Since cosine is negative, it's 2. And 1 over root 2, you might remember, corresponding to 45 degrees. So that means our angle is 135. So that means theta is either equal to 135 degrees if you're talking about degrees, or if you convert to radians, 3 pi over 4. And that's all there is to that. Okay, one more. Cosecant inverse. Now, again, cosecant inverse, reciprocal of sine, right? But I have to write out the steps first. So cosecant of theta is equal to, I'm going to pick the first one, because then that automatically means that sine of theta is root 3 over 2. And just by eyeballing that, hopefully you know that that's the special angle 60 degrees, which could also be written as pi over 3. And there is a big picture takeaway from this. The three remaining inverse functions that we didn't talk about can be thought of this way. If I want to find the inverse cosecant of x, it's the same as finding the inverse sine of the reciprocal. In other words, what we did up here, cosecant, notice we took the cosecant inverse of 2 over root 3. It was the same as, if I wrote this again, the sine inverse of root 3 over 2. So there we go. Okay, So basically, an inverse trig function of x is the reciprocal inverse trig function of the reciprocal. Okay? So there's 3 more identities to know and use. And again, just to get familiar with the inverse trig functions. What's next? We're going to find more complicated exact values with inverse trig functions. So be sure to stay tuned. Thanks for watching.